So in this exam style question, we're going to look at earthquakes. So earthquakes produce transverse and longitudinal seismic waves that travel through rock. Remember we talked about how you get two different waves produced by an earthquake with different names, which we'll get to. The figure below shows the displacement of the particles of rock at a given instant for different positions along a transverse wave. Remember we said that S waves, the secondary waves, were transverse, and P waves, the primary waves, were longitudinal. And then this is our wave drawn below, and they've labelled some points. Remember, this is displacement, this is our equilibrium line, this is our direction of wave travel. So they first start off by just wanting us to basically list some phase differences. So a phase difference between point A here and point B here, and then a phase difference between point A here and point C here. And this is really simple. There's a number of ways of doing this. We could find the horizontal distance between the two, but it's quite simple. We really just realise that this is a quarter of a wavelength, so this is going to be a quarter of a cycle. This is a quarter of a wavelength here, so this point B is a quarter of a cycle ahead of point A. How do we know this is a quarter of a wavelength? Well, this distance to this distance is half a wavelength, this distance to this distance is a whole wavelength, so this is a quarter. And so if it's a quarter of a wavelength ahead, then the phase difference is going to be, well, remember our formula. Phase difference is 2 pi d, where d is the horizontal distance, but divided by the wavelength, whereas in this case it's just going to be 2 pi times a quarter of a lambda divided by lambda, which is going to give us pi over 2. But the thing is, we don't really need to do that. All we need to see is that this is a quarter of a cycle ahead. And so if it's a quarter of a cycle ahead, then that tells us we just need to times a quarter by the time the phase of a full cycle, which is 2 pi. So it's a quarter times 2 pi, which is pi over 2. And that's kind of the easiest way to do this. Just look and see. I mean, in some cases that's not going to work. If this is not obvious, then how much of a cycle ahead of the other one it is. For instance, if it was like this point and this point or something, you wouldn't necessarily be able to see. All you could do is measure the horizontal distance and work it out. But when you know that they're a quarter of a cycle ahead, then that makes it really simple. And the same is kind of true here. So, sorry, the first one for points A and B is just pi over 2 is the phase difference. And a couple of ways of getting that. Now for A and C, the phase difference again, well, you can just see how much of a wavelength it is ahead, where it's going to be the quarter from A to B plus whatever the difference between B and C is. B and C, you can clearly see this is a half, this is a half wavelength, excuse me. But if it's a half wavelength...
Hey guys, to continue watching this video and unlock hundreds of other super concise and exam board specific A-level physics videos, just click the Snap Revise smiley face. Join me today, and together let's make A-level physics a walk in the park.